Gas stoichiometry practice. The last packet that you did, you had to do stoichiometry, where you had to take the number of grams of one substance and figure out how many grams of another substance would be used or produced in a reaction. And you're going to be doing the same thing with gas stoichiometry, except now you're also going to be dealing with liters of a gas rather than just grams of a solid or a liquid. So what you're going to see in your reading material, which is really nice, right here, is that if you have 1 mole of a gas at STP, which is standard temperature and pressure, which is 0 degrees Celsius and 1 atmosphere of pressure, then that 1 mole of a gas takes up 22.4 liters of space. So it doesn't matter what gas it is. It could be O2, it could be CO2, it could be Cl2, it could be whatever gas we're looking at. If we have 1 mole of it at standard temperature and pressure, we have 22.4 liters of it. This is actually going to make our math a little bit easier when we have to work with liters. So in this problem here, it tells us calcium carbonate decomposes at high temperatures to form carbon dioxide and calcium oxide. So I have calcium carbonate decomposing into carbon dioxide and calcium oxide. Now notice now you have these phases of matter, the states of matter. So I know that this is a solid, this is a gas, and this is a solid. The gases are the ones that we can use that 22.4 liters for if we're at STP, which all these questions say we're at standard temperature and pressure. Okay, 273 Kelvin is the same as 0 degrees Celsius, in case you're wondering. So what you're going to do, you're going to set up your typical stoichiometry problem, put your given at the top left. So here's our 3.45 liters. So I would start out by putting 3.45 liters. It says of carbon dioxide, and I know that this one is carbon dioxide, so CO2. And then I set up my grid just like I've been doing for all my other stoichiometry problems. Now in this case, since I have liters on top, and this is at standard temperature and pressure, I'm going to put 22.4 liters of CO2 would be 1 mole of CO2. Remember, that's from our notes. 1 mole is equal to 22.4 liters of the gas. So 1 mole is equal to 22.4 liters. So I didn't have to add up the masses of C and 2 O's to get this. Liters on top, liters on bottom. I changed my liters into moles, which is always our first step, is to get to moles in stoichiometry problems. And then I can go back and compare my moles to moles just like I did before. 1 mole of CO2, well, how many moles of CO2 are in my actual equation? 1. Notice this is balanced with 1, 1, and 1, so all of my coefficients are 1, which means that 1 mole of CO2. And it says how many grams of calcium carbonate will I need? Well, here's calcium carbonate. 1 mole calcium carbonate I get from here. There's only 1 of them. Then it asks me in my question how many grams. So I'm not doing liters here. I did liters in this step because I was given liters and I needed to find moles. Now I have moles and I need to find grams. So I'm going to say that 1 mole of CaCO3 would be equal to however many grams CaCO3 is. So I put grams of CaCO3. And then this time, since you're doing grams, you do have to add up the masses of Ca, C, and 3 O's. Once you've done that, you'll put that number here for the mass. And remember, multiply across and divide by the bottom. So you're going to multiply these numbers and whatever you get here for the mass of Ca, C, and 3 O's, and then divide by 22.4 times 1 times 1. Obviously, 22.4 times 1 times 1 is still 22.4, so you're just dividing by this. So don't forget to put this in here, multiply across the top and bottom, get your two numbers, divide, and that will be your number of grams of CaCO3, because liters of CO2 will have canceled out, moles of CO2 will have canceled out, and moles of CaCO3 will cancel out, leaving you with grams of calcium carbonate. You're going to do the other two problems on here just like that. Don't forget, if it tells you liters, you're going to use 22.4, and if it asks for how many liters at the end, if it had asked me here for how many liters, I wouldn't add up the grams. I would just say 22.4 liters is 1 mole. So if it asks for grams, add them up. If it talks about liters, just use 22.4 for this worksheet. If you do still have any questions, please come ask.